right? ASE means what?
Enzyme.
That destroys, like, right? So, and it destroys what? Penicillin. So there's penicillinase, that's an example of an enzyme that's made through drug inactivation. Another gene that they trade is a gene that decreases the permeability for a drug. So now the organism has a gene that makes it so that the drug can't even enter the cell. Do you agree that the drug would have to enter the cell for anti-ribosomals, DNA synthesis inhibitors, and anti-metabolites? If the drug can't enter the cell is going to be resistant. Another gene that's passed around from organism to organism is a gene that codes for a drug pump, that pumps the drug back out of the cell again. A fourth gene that they pass around is a gene that changes the binding site. If binding sites are changed, then the drugs no longer destroy those organisms. And the last gene that's traded by these organisms is a gene that will allow these organisms to take on an alternate metabolic pathway. So if I give ciprofloxacin, which is an anti-metabolite, right? If I give the patient ciprofloxacin and that doesn't destroy the organism, it could mean that the organism is now capable of switching to a different metabolic pathway, and I'd either have to choose a different anti-metabolite, or I'd have to use an RNA or DNA synthesis inhibitor. By the way, do you also think that anti-metabolites can be dangerous to human beings? Who says yes? All right, but who's not going to vote? So you won't even vote if you're not going to vote. Not even going to vote about not voting. So who says that anti-metabolites are disruptive to human beings? Who says yes? And who says no? Well, if please one person at least raise your hand for no. Please, one person, please. You're both correct. Because you see, there are certain metabolic pathways that occur in organisms that don't occur in us. Do we undergo ethyl alcohol fermentation?
No.
I wish. Right? So the idea is that there are anti-metabolites that disrupt certain pathways. You've seen this one before, so obviously here are 5 different types of genes that are handed around by these organisms. Next, you saw this slide before, correct? We've already discussed that the more times you use antibacterials, the more times you take oral antibiotics, this is what you have if you hardly ever take them. The more times you take them, eventually you're going to be wiping these out, leaving just these behind. Keep taking them, keep taking them, keep taking them, and now you'll have only this. All you need is for one of these colonies to get in the wrong place. Let's say that these are E. coli that are in the digestive tract. Do you think that these could make their way to the urethra? You're supposed to wipe front to back, right? Mm-hmm. What if one of these colonies makes its way to the urethra? And a UTI that's not going to be, what? You won't be able to destroy it with antibacterials. Because all of these colonies are what? Now resistant. So that's why the best thing to do, whenever you get a cold, you get something, I don't want to say Ebola. The best thing to do is when you have any type of respiratory infection or you have diarrhea, the best thing to do is to let it take its course first and see if your immune system can knock it down. And guess what? I'm twice your age, if not 3 times your age, and guess what? My immune system works. I cowboy up, and after a few days, I'm better, and I